Okay, let me share my screen. Let me know if you're not able to see anything on your screen or you're not able to hear me. Okay, just recap what we have learned in the previous lecture. We have explained about the continuity equation. Basically, we deal with m dot, mesh, the rate of change of your mass, m dot, right? So this is the equation that is very important that help you to score marks in your test and exam. So just to remember this one, all right? So d dt, rho v on the left-hand side is the system, and on the right-hand side consists of control volume and console surface. One is 3D and one is on the surface area, right? But both will give you m dot, which is a mass flow rate. Okay, and then when your system apply continuity equation for non-deforming control volume, means the control volume doesn't change, and you apply the continuity equation, means your system, your dm over dt is equal 0. So all these two components, CV and CS, will equal to 0. So this from this equation, you write in your answer sheet, you get marks. And when you apply, when you see that the question asks you to apply continuity equation, you write the CV plus CS equals 0, then you get another point. You score another point for that. Okay, today we look at one of the example question. This one will be the same in your tutorial question chapter 2, question 3. Yeah, question 3. So this is just a warm-up question. This question is using conservation of mass. However, we are having an unsteady flow. Having an unsteady flow. So what happened when we have an unsteady flow? So we are given a scenario, and most of the time for this module, we will look at a realistic case. I'll give you a scenario where you, from the scenario itself, you solve the question using the equation. So the scenario we have here is that we had a worker works in a confined space, involve the consumption of oxygen and its replacement with other gas such as CO2. To prevent this from happening, a confined space need to be ventilated. Means it have to be the air have to need to be able to flow. Although there is no standard for the air exchange rate, a complete exchange of air every 3 minutes have been accepted by the industry as providing effective ventilation. So there is information here that a good ventilation criteria is that every 3 minutes the volume inside the control volume confined space have to change in 100%. So it means that the volume have to change every 3 minutes. And then the scenario continue. A worker is performing a maintenance in a small rectangular tank with a height so and so, in this case 10 meter, and a square base of 6 times 6. So by looking at this statement, you already know that you're having a volume. So you calculate the volume, you get marks for volume. Quite easy. Then fresh air enter through a duct or a hose. So this one, the fresh air will pump into the volume through a diameter of 80 cm hose and exit through 40 cm diameter port on the tank wall. The flow is assumed steady and incompressible. Okay, so in this case, there are some condition or there's some keyword given to you. You need to be aware. First, the volume. It will be very helpful if you're able to sketch the control volume or the focus of your solution. In this case, you are given a volume, so it will be very helpful on your side to draw the volume that we interest to solve. So in this case, this worker is inside this tank. Okay. Yeah, again, apologize for my drawing, but you get the idea. So small tank with a height of 10 meters. So when you solve question, remember to change all your unit into unit SI. Yeah, so meter, and base is 6 times 6. So we have 6 times 6 here. Okay. And the fresh air enter through some holes. So let's say it pump through here. So let's say this one. The diameter of the hose is 80 cm. So this is also one of the trap in the exam or test. So remember to change this one to meter. So later on, this one will become 0.8 meter. Okay, and this one will become 0.4 meter. We're having a steady flow and incompressible. So these are the two words that help us to solve our question a bit more faster. All right, now what does the question ask us to solve? We are given two tasks here. So we need to determine the extract rate needed. Extract rate needed. So in this case, you are given some hints here also. In a unit of meter square over minute. So you need to find the volume and the time required for this case, exchange rate. The second case is that we need to find the velocity of the air entering and exit the tank at this exchange rate. So when you find the A, then you need to find the velocity entering from the left and then go out to the right. Okay, this is just a simple case where we apply what we learned so far. Okay, so I will highlight all the important keyword that I mentioned just now. All right, so what we need to do is that we need to find the exchange rate and velocity of the air. Okay, so I copied all the important point I put on the top of the screen here. All right, and important, make sure you change the unit SI for all the unit that you use. Now for A, we need to find the exchange rate needed for this tank. So recall your Q. Q is the volume flow rate given by volume divided by time. So the volume, just now we already draw for you. So the volume is 6 times 6 times 10. You get the volume. Time in the question is 3 minutes. So you just take the volume divided by the time given. You use your calculator and you get the answer. So normally, how we mark, you write the general equation, 1 mark. Calculation steps, 1 mark. Answer, 2 marks. But if you forget to write the unit, maybe your answer you write in your answer sheet, you write 120 straight away. Without the unit, you only score 1 mark. It will be 50% discount if you forget to put in unit in your answer. Okay, so for example, this kind of case is quite straightforward. So how we mark, usually we'll look at the equation. You write equation, you get marks. Then you substitute the value accordingly, you get 1 mark. You give us the correct answer with the correct unit, you get 2 marks. So usually you will run like this for this module. Any one of you have any question? To find the A is quite direct in this case. All right. Any one of you don't understand how you get 120 meter cube over a minute? Okay. Now this is a tutorial question. So in exam, sometimes we will ask what is the meter cube over second. So you need to know how to change all the unit. It might ask you in second, it might ask you in hour, and so on. So you need to be sensitive to the wording used in the question. All right, so stop me if you have any question or you're not sure what is happening on your screen. So we look for B. B is a velocity that is entering into the tank by using the exchange rate that you calculate just now in A. So we need to use the continuity equation. Continuity equation means the m dot inside your system equal 0. So you write this continuity equation, you get 1 mark. Again, continuity equation always only need to consider 2 dimensions. One is your control volume, one is your control surface. All right, and the format standard already. Okay, you write this equation, continuity equation, rho over dt, del over dt, integrate of your density times volume. Again, for this module, if you look at the V with a center line, means volume. The V without the center line, it means velocity. Okay, so integrate for the control surface here. You integrate the rho times the velocity vector and the dA. So last lecture I already show you how to find the positive and negative value depending on two things. One is the wall. Wall velocity and the area vector. You look at these two arrows, you can find the dot product. If the arrow is same direction, you get positive value products. If your velocity is going in, right? For example, this case, V, and this is your A. Again, A always pointing out, always pointing to the opening direction. So in this case, if the arrow is opposite each other, you get negative sign. Okay, all right, let's continue. The next one, also another bonus mark for you. So this one, you get 1 mark already when you write out the continuity equation to solve. The next one, you make full use of the keyword given in the question. You have a steady word there, steady flow. So the next step is in your answer sheet there. You write steady, draw an arrow, put in equal 0, you get another point for steady flow definition. Okay, so by this simple equation, you get 2 marks already for B. All right, so every time if the question mentioned you have a steady flow, so by all means, go to your equation and then look for control volume component, draw an arrow, write steady, write equals 0, you will score 1 mark for steady flow definition. Okay, the next one will only the next one will be using what is happening for the continuity equation, meaning all the mass going out minus going in will be 0, means you have a stable system. What is going in equal to what is going out. So you can write this form, or you can move this component to the right hand side. You will get m dot out equal m dot in. Same definition. Okay. So how do you get m dot? M dot give you use the rho times the area times the velocity, you get m dot. All right. By looking at CS component, this is rho, velocity, area. Okay. All right. Why they are two in and out there? Because in this question, you already tell you that you have one point for it to pump in the air, and then another area, the air will go up. So we assume that the inlet is from this side. So this is your in, this is your out. So what is going in must equal to what is going out. So you write rho A V out, velocity out here, minus sum of the rho A V in equals 0. Okay, so this is 1 more mark, this is 1 more mark. All right, then you continue solving the question. You just now you write rho AV out minus rho AV in equals 0. Then you start substituting inside the number. Now, in this case, although we don't have density in our question, however, when you simplify the equation, you can take out the rho, because the rho for the air is the same inside this mathematical model. If you move this one to right hand side, you can cancel the rho. Okay. So there's no change of density in this case. Yeah. How you know there's no change of density? You look at this word. When you see incompressible in your question, it means the rho is constant. Okay, go back to your physics understanding on the density. Okay, constant. Apologize, because I'm using mouse to write. Okay, rho is constant when you see the incompressible. Okay, imagine you're having a cube. There's no change of volume, and you're not able to press the fluid inside this volume. It means that there's no change of mass and there's no change of dimension for your volume. So your rho is constant. Okay, again, your rho unit is kilogram over meter cube. There's no change of if your fluid, if your air, right, if your flow, if your fluid is not able to compress, your mass not going to change. Your dimension not able to change because you're not able to compress it. So no deformation happen. Okay, so incompressible would help you to define. So in other words, in your answer, if you write incompressible, mean that rho is the same or rho equal constant, you get another point for showing your understanding for incompressible. Okay, quite easy to score for this module, right? As long as you look for all the keyword, you write the definition, you will score marks. So since they are incompressible, rho is the same, you can take out, right? You can take out like what I label with the blue arrow on the screen here. Then the next, you just process accordingly to the value you have in the question. So you only have area times volume out. Then you move your negative to the right hand side, will be equal to area in, velocity in, and the product of area times velocity, you get your Q, which is your volume flow rate. And volume flow rate just now you define, right? Your Q you define in section A, this one you define. So what is the difference of the velocity? So you just rewrite the equation. So V out equal to Q divided by A out, because the area for your outlet is different. Okay, your area is, the out is 40 cm diameter. Be careful on the word, because some of you will be confusing when you calculate the area of a circle. All right, so area of a circle give you pi r square or pi d square divided by 4. So be careful. If you are used to pi r square, remember to divide by 2 and change the unit SI to meter. Okay, so these are the mistakes that every semester I see always the one student will make these mistakes. He forget to change, or he accidentally or overlook the diameter. Okay, if you already convenient with pi r square, remember to switch to radius, this one divided by 2. Or you can use the normal pi d square divided by 4. Remember to change to unit SI. Same with the in. Area of the in is 80 cm diameter. So you use pi r square. Okay, how do you know that you can use a circle area? Because the wording of hose and diameter. Okay, if you have a hose with a diameter, it means that you're having a circular shape of pipe or something. Means that you can use a cross section of the circle to find. The rest is just substitution of the value from the question. So if you press your calculator, you'll get your velocity of the in, you'll get 3.979 meter per second. You get 2 marks. Again, if you forget to put in the unit, you only score 1 mark without the unit. So be careful on the unit. So same, if you press your calculator, you will get for velocity at the out section out there, you'll get 15.915 meter per second. You'll get another 2 points. Okay, for this module, throughout the semester, you need to give your minimum decimal 3, decimal place. Meaning here, minimum 3 for your answer. All right. Yeah. So this is just a reminder. So this explains how you use your equation. All right, this one, continuity equation. How do you use when you have a direct case? They give you only a few keywords and you manage to find the answer. All right, so today I introduced to you the word steady and incompressible. What the effect it can be done for your equation and how they help you to score marks in your answer. Okay, any questions so far for your first tutorial question for today? Is it clear for you?
So I got one question.
Yes, go ahead.
So if I answer right, I straight away put E equals to V, the last one.
Okay, hold on.
Yeah.
Clear this
out.
one.
I
So
put the last one, and then
put
I
this
give
one.
the answer.
You give this one. Let's say you give this one. Okay. Go ahead.
There is a direction of the marks.
What do you mean? You means you only write this one, or?
I write the last one, and then I give the answer.
Oh, it means you give this answer. Okay. So normally it's quite risky because sometimes when you press wrongly, you will get the wrong answer. So I would recommend you substitute the number first. You write the substitution of the number here.
Yeah, I read that, sir.
Then you write
the equation.
You write inside the equation. Can. As long as your final the equation is there. Let's say you write this one, you write these two equation, and then you give me the answer directly. Also, I'll give you a full mark for the answer. However, if you give the wrong answer, you might lose the 2 marks here, and then also you might lose the marks for calculation. Means if for this case there's a number here, there's number here. So if you only give the answer, let's say you only give V in equal to 3.979, you will get full marks with a unit. However, if you give me answer V in, let's say you press your calculator wrong and you give me 5.2, and you submit your answer, you will lose the 2 marks and you'll lose the 1 mark here. There's no substitution of calculation marks for you. Means you only score for the general equation, right? Yeah. So this is how I mark the paper. Clear? Is that clear for you?
Yes, sir.
Okay. Any more question before we move to the next one? This is quite direct. Okay.
No, sir. No questions.
Okay. All right. Let's move to the next one. Next one is your tutorial question number 4. Okay, this is a more exciting one. Okay. Now you're given an airflow. Another word coming out, which will help you to score marks already. You see the word steady, so it means you have a steady flow. Between two sections, long and straight, and you're given a 4 cm diameter. And again, what we interested is the DI or inside diameter. Remember, always change to unit SI, which is 0.04. Okay. All right, then uniformly distributed temperature, pressure at this section given. So you're given this diagram. Average velocity, there are non-uniform velocity here happening. At section 2, which is here, as you can see, there is a non-uniform. Okay, what mean by uniform and non-uniform? So if you're seeing arrow here, arrow like this is uniform flow. This is uniform flow. Okay, uniform flow. And you're having a parabolic shape. Then you're having a non-uniform flow, and you're given the quantity 1000 cm over second. All right. Assume air acts as ideal gas. Remember the unit here is cm. Be careful, right? Assume air acts as ideal gas. So calculate the average air velocity in this area. Okay. Now before you start, you will always need to remember what is going in must going out, which is the continuity equation. M in equal to M2, or what is in equal what is out. This is the first concept that you must always remember before you solve. And you're given the pressure at one end, pressure at another end. Temperature is different. One is 200 degrees C, one is 100 degrees C. Okay. When you solve this kind of question for this module, especially for chapter 2, always you will see a control volume. Some question, if we draw a control volume for you, some will not. Okay, so you need to identify the type of question you have. All right. Of course, for tutorial question, most of the time we will just show you where is the control volume. In exam, normally we will remove the control volume. Okay. The flow is coming from the left to right. Okay. So how do we solve? How will we find the average air for section 1? By using the equation, continuity equation. So move forward. We write all the information we have. What is missing is your V1 is missing. Velocity at point 1 is missing. V2 is 1000 cm over second. And the diagram that you see over here at below the screen here is what is mentioned by the question is non-uniform. So we need to change the red color line, which is non-uniform, into the blue color line. Means we can mathematically transform the red color shape into a blue color shape. However, when you change the red color shape to blue color shape, the notation that you use, the velocity have to be had a hat above. Means that it's an average velocity. It becomes an average velocity and not the true velocity inside the system. Okay, so this is another new things for today's lecture. In this tutorial question, we demonstrate to you how we change the non-uniform speed. We change into we assume that we are having a velocity in average, which is a blue color shape, so that we're able to analyze more. We can simplify the scenario, and then we solve it in a faster way, faster time. So when you see the V hat, it means that you already converted the red color line into a blue color line, which is average, which is uniform flow. Uniform flow with a value of 10 cm per second. If you go back to the question also, it will give you this word average air velocity, means that is already converted to V hat. 1000 cm per second. Okay, although it's a non-uniform distribution scenario you have, however, the word you see average air there, it means that you already converted into uniform shape, then you can analyze. Okay, we have done with the explanation of all the notation. Then the next part will be the normal one. You write the continuity equation. You write this equation, you score 1 mark. All right, continuity equation consists of control volume plus control surface dimension. And the next step, I think you can guess, which is the steady flow steps. So you write the continuity equation, you get 1 mark. You look for steady flow, you write the steady, draw an arrow, write equals 0, you will get 1 mark for these steps that tell that you just demonstrate that you understand what is steady flow on the continuity equation. What happens if you have a steady flow when you apply the continuity equation? Means that you can cancel the first component for control volume component here. Okay, this one equals 0. And you know that this part is m dot. So you want to find what is in equal to what is out. So in this pipe here, you're actually having two area here. One is in on the left hand side, one is out on the right hand side. So this is in area, this is out area. So you have to calculate the sum of the mass flow rate inside the system. So you consider m dot out minus m dot in equals 0. Because you are applying the continuity equation, you get another marks for the steps and equation. Then after that, you expand the equation. What is the m dot? Basically, you just copy, or you just refer to the equation of your control surface dimension. Rho, you write rho a v, you copy v out equal to rho AV in. Then you get another marks for this expansion of your m dot equation. The rest, okay, be careful, because let's see whether you can cancel the density or not. You need to read back the question. So if the question mentioned incompressible, then you can cancel out the, in this case, it do not mention that it is compressible. And also the temperature is different. As you know that when the temperature different, your density is going to change. Okay, because of the temperature. So temperature at 1 will give you rho 1 with its density 1. Temperature 2 will give you density 2. So in this case, you cannot cancel your rho here. So be careful. Huh? So previous example, you see the word incompressible, you can cancel the density. However, in this case, in the question itself, there is no incompressible. So the next idea, you look at the temperature. So if temperature and the pressure changing also, it means that you have one set density for section 1, one set density for section 2. So you're not able to, you cannot straight away cancel your density like the previous example. Okay. So we have a average velocity here, which is the v hat here. We have a v hat at number 2 here, which is 1000 cm per second. So straight away we can equal the two equations here. Just a side note, in this case, because your pressure and density, pressure and temperature is different in two sections there, or inside the pipe, so it's fall under compressible case, and the density will not be same. So you cannot cancel the density like what we did in the previous example. Okay, we continue solving. So you have a rho A V, which is a V hat with the, it means that you are going to use the average velocity. Why average velocity? Because we already convert the red color line, which is a non-uniform flow, into a uniform flow scenario. So we are using v hat rather than using the v in a normal condition. Okay. All right. As you go deeper in this chapter, later you will see I'll give you equation for this one. Then you need to integrate the velocity. Then it will be a further step for integration steps. However, in this example, we will just give you a direct case where you can straight away use the average velocity. Okay, now what about area? Area is the same. Why? We can know that it is same because from the question there's a highlight, there's a catchy word, or there's a keyword there. When you see the long straight pipe, long and straight means you have the same cross-section area for the pipe. So, and you are given the size of the diameter. So from this two information that I highlight on the screen here, you can find the area. And again, be careful. The question gives you diameter. So if you're so used to pi r square, be smart enough to change accordingly. Okay. Or you can use the normal one, pi d square over 4. Both give you same answer. Okay. We go back to the solution. So in this case, area is the same, right? So you can cancel. So when you cancel something in your answer, please explain. Don't suddenly cancel and then without explanation. So when you say that the area is the same, you can cancel. So you get another point for the green color arrow. Then you only have row 2 V2 equal to row 1 V1. And then you can rewrite, because we are interested to find what is happening for your section 1 velocity. You can rearrange this equation into a more simpler direction, or equation. So in this case, you have a V1 equal to row 2 divided by row 1 V2. So you know that the question asks you to assume air as an ideal gas. So you need to recall, because this is a year 3 module, we assume you already take thermodynamics module already. Okay, so you have to recall what is ideal gas equation, that you learned in thermodynamics. All right. So when you have an ideal gas scenario, recall what you learned in your thermodynamics. Rho equal to P divided by RT. Okay, rho equal to P divided by RT. And there's a conversion of temperature. There's an equation to convert the temperature. It depends on the Rankine number or the R value that you use. Okay, so some R value give you in, sorry, this is not R, but it should be Kelvin, right? So apologize, this is not R, it should be Kelvin. So your R value, if you refer back to your thermodynamics chapter, your R value have two set. One is in the Celsius, one is in the Kelvin unit. So if you use Celsius, you can straight away use the Celsius here. But if you use the R value of Kelvin, then you need to change accordingly. So this example is just recall. You need to recall what you learned for ideal gas. Rho equal to P divided by RT, and this equation will not be given in the SM. You need to recall. So you represent why we need to use this equation, because we don't have the rho value in the question. However, we are giving some hints that it's an ideal gas. So there's a purpose why we put ideal gas word inside the question. It means that we want you to use the parameter given in the question to solve. So in the ideal gas, there is one equation that link your rho to the pressure and temperature. Okay, the rho and temperature. So although we do not know the R here, so when you substitute your rho2 equation inside here for your P1, for your rho 1 and rho 2, you rearrange the equation, you arrive at this one. Okay, you arrive at P2 T1 divided by P1 T2 times the V hat 2. Okay, from this step to this step is basically your mathematics skill already. Okay, what we can guide you is you need to recall the ideal gas equation. Substitute rho equal to P over RT. If it is 2, then all these are 2, 2, 2, 2. And you know that for air, if you are using the same medium, the R value is the same. So you can cancel your R in your simplification steps. So you have V1 equal to P2 T1 divided by P1 T2 V2. The rest is the substitution of the numbers that you see on the screen, especially on the top of your top left corner of the screen. You just substitute what you have here. Just need to remember, just need to be careful on the mega here, okay? We need to recall what is mega, kilo, micron, pico, and so on, yeah? So when you see mega, it means 10 power 6 Pascal. And remember to change all the unit here. It depends on the final answer that you need. All right. So it's just substitute. Again, there's a typo error here. It should not be R. It should be K, Kelvin. Right. So sorry, this is not R. It should be Kelvin. It should be Kelvin. Right. Typo error here. Just take note. When you later I will upload the slides, my PowerPoint slides. So you might be seeing R there. So remember, there's a typo error in my slides. Just make some note in your revision notes there. Okay. So this is Kelvin. Both you change to Kelvin. Okay, because you're using R in this case, right? But if you just use the Celsius, also you'll get the same answer, because in this case you are removing the R, and also the ratio between T2 and T1 will be the same if you use Kelvin or Celsius. You still arrive at the same ratio, no matter how, if you use Celsius or use Kelvin, it will give you the same ratio. So in this case, it doesn't affect your final answer. Okay, right. So at the end, you substitute all the answer for P1, P2, V2. You'll get 228 cm per second, or sometimes the question will ask you to put in meter per second. Okay, so when it's meter per second, you need to put as 2.80 meter. Okay. So this is how you solve for this kind of question, by looking for the keyword inside the we call in the question. Okay, there are two. Okay, either in cm or meter, depends on the question, how the question asks you. Okay, again, there are typo error in my slides. So this is not R, but it should be Kelvin. Oh, all right, I changed to Kelvin because I'm using the R in Kelvin unit. Right. So this is how we solve for your tutorial question number 4. Any questions so far? Let me end the recording.